In urban areas, water is supplied to your property from the street water mains of the utility company. At the edge of your property line, there is a shutoff valve controlled by the utility company called the curb valve, as shown in the picture on the right. This will be turned on when you activate service or shut off when you do not pay your bill. The house service main is actually the pipe that delivers water to your house and can be seen ending just inside of the house. Once inside of the house, the water supply pipe becomes the responsibility of you, the homeowner. There should be a shutoff valve and potentially a meter inside the house before the inlet branches. Inlet pipes are usually made of iron, brass, copper, or even lead in an older home. You can usually identify lead by the horizontal pipe's connection joint. There will be a spherical bulge. If there is no bulge present, you could also scratch the surface of the pipe gently. Lead is relatively soft and will expose a silver or gray color. When you have a lead pipe system, you should have your water analyzed. Unfortunately, you will have to bear the cost of replacement, and this could be up to several hundred or even several $1,000s. As you follow the inlet pipe, there might be a water softener or filter before you get to the distribution piping. Make sure this is securely mounted. Look for obvious problems such as leaks around the joints and fittings, as well as improper connections. A filter should be installed before any branch pipes and softener or water pressure tank. We often hear of hard water, which is really water that has too much iron within it. If you have cloudy water at faucets, even with a filter and softener, the softener may need to go before the filter to reduce the amount of buildup in the filter cavity. Any storage or pressure tank tells me there was probably low pressure at the street main or in a well. The normal water pressure range can be 20 to 40 or 30 to 50 pounds per square inch. This tank must be properly filled with air to function properly. However, over time, the water absorbs the air and your tank becomes what we call waterlogged. This is easier to fix than you would think. Cutting the power, draining, and injecting more air into it is all it takes. However, there may be a bladder layer designed to separate air from water, and this entire unit will have to be replaced. There are a couple of tests you can perform to check for a waterlogged tank. One way is to simply listen for a pump that turns on and off every few seconds. The other way is to simply tap on the top of the tank with your knuckle or a metal object and listen for a hollow sound, which means it is fine. Then tap on the bottom of the tank and listen for a dull thud. Hearing this thud at the top and the bottom indicates a waterlogged tank. After looking at all of the accessory devices you may have, there should be a cold water pipe that is directing some of the water to your water heater. The water heater will be either a standalone unit or it can be part of the heating system, which we'll discuss later. The distribution piping will run from the water heater to various branches and fixtures. Hot water pipes should ideally be about 6 inches from cold water pipes to avoid transferring any heat to the cold system. Distribution pipes have two components: supply mains and fixture risers. We see the supply mains in the basement or crawl space, but fixture risers are normally concealed behind walls, and getting to them can sometimes be a pain. You will normally see the standard iron, copper, or brass pipes, yet plastic piping is allowed in many localities. Inspect all of your visible pipes for leaks every so often. If your home is heated by a hot water or steam system, not only will you see a branch from the main supply inlet to the water heater, but expect to see a cold or hot branch to the boiler as well. With copper and brass pipes, you can usually tell the difference in cold or hot pipes by their color. Cold pipes tend to be darker. Don't confuse condensation on your cold pipes for leaks. From our basement lesson, we learned that condensation is often caused by excess moisture in the basement or crawl space. To avoid this, pipes should be insulated or a dehumidifier should be used. If you recall, copper pipes are vulnerable to pinhole leaks. In addition, copper pipes often have a greenish residue at their fittings. This is typically a reaction between the water and the soldering flux. Leaks usually show up around joints as mineral deposit residues. Iron pipes are usually galvanized, meaning they have a zinc coating on them. One way to ensure you have galvanized iron pipes is to use a magnet. These pipes are known for rust and corrosion building up on the inside before any signs appear on the exterior. Be suspect that low pressure at your fixtures may be a result of this plumbing system. Plastic piping can become brittle with age. Cracks are known to form along the sides of the pipe. Also, old pipes that are hit or bumped can snap. Yellow brass is vulnerable to corrosion, although it's known to last about 40 years. Red brass piping is actually yellowish brown and can last even longer, usually around 75 years. Like copper, this piping is vulnerable to pinhole-sized leaks. If you see any white deposits, this is an indication of pinhole leaks that are evaporating. These deposits usually seal up their own pinhole leaks, but this is only temporary. Eventually the leak will grow. These pipes should be replaced. All of your fixtures are at the end of the water supply and the beginning of the drainage system. Most fixtures will have both hot and cold outlets. Look for leaks around the handles and spouts. Are there any signs of past leakage? There should also be an individual shutoff valve for the water supply to your fixtures. For example, the fill valve in your toilet needs adjusting if you hear a whistling sound when the toilet tank is filling. The drainage system of your house consists of 3 parts: traps, drain pipes, and vents. Under your sinks, you will see a U-shaped trap. There is actually water in the bottom portion that forms a seal, preventing sewer gases from entering the room. Wastewater flows from this trap down a drain line and out to the sewer system entirely by gravity. Drain pipes are larger in diameter than distribution pipes. In your community, you may be required to have a trap on the house drain line. A fresh air inlet is required to maintain the atmospheric pressure and to ensure proper air movement within the system. This inlet should be covered with some sort of screen or perforated metal. A shallow well draws from an aquifer less than 25 feet deep. Aquifers found more than 25 feet deep are referred to as deep wells, and it's not uncommon to see a well several hundred feet deep. To some extent, soil acts as a natural purifier, but if you have a well system, you should have your water analyzed once a year for bacterial or chemical pollutants. Unfortunately, the only part of the well system you'll be able to see is the above-ground casing or well pipe. The top of the casing should have a cap that is secure. Sometimes the casing or well pipe is below ground. There is a strong possibility that surface water can enter or contaminate the seal installed where the cut ends meet. If there is a submersible pump installed, wires will be coming out of the ground next to the casing and going into the well cap. These wires need to be protected by a conduit of some kind. Finally, if your well casing is plastic, check it for cracks or broken sections. Jet pumps consist of a jet assembly and a centrifugal pump. Think of a small paddle wheel driven by a motor. As the wheel turns, it imparts energy to the water, thus increasing its velocity and pressure. A jet pump will either have 1 or 2 pipes going into the nose, 1 pipe being for shallow wells and 2 pipes indicating deep wells. Jet pumps are a lot less efficient than submersible pumps because a large portion of the water has to be thrown back into the water to pull more water back in. This fast-moving water stream enters a small hole and creates a vacuum that pulls more water back into the well. If you have a jet pump, this is why you have to prime it by filling it with water. If a section of the system does not have water, called an airlock, the system won't pump any water. A frozen pump is the most common reason for replacement. A submersible pump is an electrically driven centrifugal pump designed so that both the pump and the motor can operate underwater. hence the name submersible. Water is drawn to the unit through screened openings between the motor and the pump. A single discharge pipe connected to the top of the pump runs to a storage tank. Typical submersible pumps can pump 7 to 10 gallons of water per minute. An advantage of submersible pumps is quiet, dependable operation. Submersibles are relatively maintenance-free, but when a problem develops, the entire unit has to be pulled out of the well. First, is sewage backing up into your house? Second, do you see or smell wastewater on the surface of the ground? For a leaching field to function properly, there must be sufficient voids in the soil. Over the years, these voids fill with suspended solids, thus reducing the rate of absorption. Look for wet spots or lush growths of grass accompanied by odor. A septic tank should be cleaned every 3 to 5 years and can last upwards of 20 to 30 years when maintained, sometimes even longer. Normally, 2 problems have to occur simultaneously before the water supply becomes contaminated. First, there must be a physical connection. Second, a backflow situation has to occur to pull contaminated water through the cross connection and into non-contaminated water. A backflow typically occurs when a street water line breaks. For example, let's suppose your neighbor has a pesticide or insecticide attachment on their hose and they are spraying their lawn or garden. A water line has just burst not far from you. If your neighbor does not have a dual check device or vacuum breaker that prevents backflow installed on their spigot, the chemicals he is using get siphoned back into the street water line and distributed to everyone through their fixtures. A dual check device or vacuum breaker should also be installed on handheld shower heads that can be immersed in a tub of chemicals or dye. There should also be dual checks on condensate lines, hose bibs, laundry tubs with hose bibs, bathtubs with a spout fully submerged, and water conditioning systems. In addition, any small pipe draining into a larger pipe requires at least a 1-inch air gap to prevent backflow.